In this video, I'm going to be looking at solutions from the Chapter 9 review. I'm working from page 429 in the McDougall-Littell book. I've copied these over to another page so I can write on these. So the first set of directions ask you to identify the family of each of these special right triangles. So these could be triples, they could be 45, 45, 90, 30, 60, 90s. Anyway, if you look at the first one, you multiply by radical 3 and you double. That's a 30, 60, 90 triangle right there. In B, notice we have all three sides. If you divide out 3, you get 3 and 4 and 5. So that is a 3, 4, 5 right triangle. All right. This one here, if you divide by 2, you get a 5 and a 12. This is a 5, 12, 13 triangle, which, by the way, if you double the 13, you get 26. So 5, 12, 13, they didn't ask for that, but 5, 12, 13 triangle. This one with the 4 and the 8.5 is a little bit strange, but I realized if I doubled both of these sides, 4 doubled would be 8, 8.5 doubled would be 17, and that's actually a little 8, 15, 17 triangle. And finally on E, it's a right triangle with 2 congruent sides. That makes it an isosceles right triangle, which means it also has 2 congruent angles. And that means both those angles have to be 45 degrees. So that is a 45, 45, 90 triangle. All right. Problem number 3 asks us to find missing lengths of sides of right triangles. And again, we've got all kinds of different right triangles. I've done this on another sheet. I could use the Pythagorean theorem here. However, I noticed that this is divisible by 2 and that's divisible by 2. So this is coming from an 8, 15, 17 triangle being doubled. So that missing side is going to end up being 30. For part B, it's a 30, 60, 90 triangle. You double the short side to get the hypotenuse. So that side would be 5. You multiply the short side by radical 3 to get the long leg. So 5 radical 3, and those are missing sides. All right. Question C. This is a right triangle. We've got a side length of 24, hypotenuse of 25. You could do the Pythagorean theorem. X squared plus 24 squared is equal to 25 squared. But if you know your triples, this is a 7, 24, 25 triangle. D. Again, you could use the Pythagorean theorem, but I noticed I can divide these each by 3. And this is a little 3, 4, 5 triangle that got tripled. So that's ought to be 15. This one here, again, you could use the Pythagorean theorem. X squared plus 3 radical 5 squared is equal to 5 radical 5 squared. However, I noticed that I can divide this by radical 5 and get 5. And if I divide this by radical 5, I get 3. And so that's actually a little 3, 4, 5 triangle that was multiplied by radical 5. So 4 radical 5 is going to be the missing side. Let's see. F. This is a 40 and a 41. And there's a 9, 40, 41 triple that I know. You could also have made this side x. You could do x squared plus 40 squared is equal to 41 squared and solve, and you'll still get 9 if you didn't know that triple, which is not a super common triple. All right, little 30, 60, 90 triangle here. I'm going to turn it upright. The 30 side is right here, so the short side is opposite this. Short side gets multiplied by radical 3 to be 15. So what that means is I'm going to have to take 15 and divide by radical 3. 15 over radical 3, that can be rationalized and simplified a little bit. That's 15 radical 3 all over 3, but 3 goes into 15 5 times. So this ends up being 5 radical 3, okay? Going back to the patterns, you double the short leg to get the hypotenuse. 5 radical 3 times 2 would be 10 radical 3. And that is my missing side length on G, 10 radical 3. H, if I double 3.5, I get 7. If I double 12, I get 24. This is a 7, 24, 25 triangle that was cut in half. So this side will be half of 25, which is 12.5 or 12.5. All right, let's see, H, I is next. We have if you divide 10 by 2, you get 5. 24 divided by 2 is 12. 5, 12, 13 triangle is doubled, so that side is 26. Side J, it's a 45, 45, 90 triangle, isosceles right triangle. You multiply short legs by radical 2 to get the hypotenuse, so you can divide by radical 2 to get the side lengths. You get 8 radical 2 over 2. 2 goes into 8 4 times, so 4 radical 2 are your 2 missing sides.